In the past few lectures, we've been looking at clustering models. These were the first type of unsupervised learning models where we were trying to learn something interesting about our data. For example, how they cluster, how the data points cluster together. In this lecture, we're going to move to our next set of unsupervised models called matrix factorization models. And specifically in this lecture, we're going to discuss the collaborative filtering problem. The motivation for this type of model is the object recommendation problem. So of course, I don't need to convince you that matching customers to products is an important practical problem that many companies would be interested in being able to do well. And we can often make these connections using user-provided information about these products. So for example, Netflix allows users to rate movies. There's that data. Amazon has data where they allow their users to rate their products and also to write reviews about them. Yelp lets users rate businesses, also write reviews about them, upload pictures, etc. YouTube allows users to like or dislike videos and to write comments about them, among many other different examples, and even within these examples there's other information that we possess. So a recommendation system can be applied to any of these problems where we want to somehow take all of this information that we have and now match a user to an object to make a recommendation. Specifically, we want to say a user has not given me any feedback on this product, but I'm going to assume that's because that user doesn't know anything about the product. So do I want to match this user together with this product? What do I think this user would think about this product? Or what do I think this person would rate this movie? And I want to use that now to help make predictions and about what a user is going to like and to make recommendations to that user. There are a few strategies to doing this. So this is a big problem with many different approaches. One general subset of approaches can be referred to as content filtering. So this is not the focus of the lecture today, but to give an overview of this important approach to it, what content filtering does is it takes known information about the products and it takes known information about the users to create profiles of the two. So for example, with products we have information about the movies, we have information about the price of the product, we have descriptions that are maybe provided by the producer of the product, and so we extract information about the movie. We know it's an action movie, we know what year it was made, etc., etc. We get a profile of descriptions about this movie. We also then do the same for each user. So we have demographic information. They maybe fill out a questionnaire. So let's look at one example. The online radio Pandora uses something called the Music Genome Project to make recommendations, among other approaches, I'm sure. And so what this does, this approach, which is a content filtering approach, is to allow experts to score each song in the database based on hundreds of characteristics. So we could pick a song and we could say this song has a lot of guitar in it, and it has a female singer, and it's 4 minutes long, and it's very loud. It has all of these descriptions that we assign to it. For example, by checking off boxes. Is this song loud? Yes is a 1, no is a 0, and we have a long list of these descriptions. And then a user will create a profile, and many questions will be asked to this user about his or her preferences, like what types of music do you like? What are some examples of songs that you like? And given all of this information, each user now can have a profile created for that person. And then based on the profile of the user and the profile of the song, they're matched together to see how similar is the profile of each to each other. And in this way, recommendations can be made. So it's an intuitive approach. If I say I like rock music and I know that this is a rock band, then perhaps I'll like that that band. So that's a way to do it. But notice that this approach is not using any behavioral information. It's not using any of my listening behavior. It's not letting me rate particular songs or particular products, or looking at my viewing behavior. It's not taking into consideration the actual patterns of how people are using these products, etc., etc. So that leads to the collaborative filtering approach. So collaborative filtering is a fundamentally different approach to this type of a problem. What collaborative filtering does is it takes users' inputs, for example, users' ratings of movies or users' viewing behaviors, and then it tries to make future recommendations based on the actual data that it's given by the user. And it's going to ignore any sort of a priori object or user-specific information. So it's not going to care whether a user is young or old. It's not going to care whether a song is a rock song or a classical song. It's only going to purely base its recommendations on what users give as feedback to a particular product. So one example of this is a neighborhood-based approach, and this is a good intuitive explanation for the difference between collaborative and content filtering. So for example, what we could do with a neighborhood-based approach is try to define a similarity score between me as a user and every other user in my database. And a way to do that would be for me and another person to ask how many objects, so let's talk about movies to make it concrete. How many movies have we both rated? So what's the overlap of our ratings in terms of the movies that we both have watched and rated? And then given that overlap, how much do we agree? So if I tend to agree with another person very much, then I'm going to be very close to that person. If I tend to disagree with that a different person very much, then that's actually also good information. I want to take that into account. So I get a proximity between me and every other user. And then, based on those proximities, I'm going to let other users recommend things to me. So for example, if I agree with this person very much, and this person watched a certain movie and gave it a very high score, high rating, and I have not given any feedback to that movie, then I'm going to let that person recommend, that movie to me by saying, because we agree so much, that I most likely would give this movie a high rating, and so I should watch it. So that's the idea behind neighborhood-based approaches. So notice the thing that's going on here is that there's no background information. The same exact approach can be used for any sort of a recommendation. We could be recommending songs, we could be recommending books or movies. All that matters is the feedback that people have given to products, and then we're trying to pair up people with other people in order to recommend objects to each other. And so before I discuss the main collaborative filtering algorithm I want to go through today, I should also quickly mention that these two approaches, the content filtering and collaborative filtering approaches, are not mutually exclusive. We can often use content information and take that information and build it into collaborative filtering models to improve the performance. So both techniques actually can be combined. But in this lecture, I just want to focus on one technique, specifically with location-based collaborative filtering methods. What we're going to discuss is a method for embedding objects in a latent space. So for example, we'll take movies like Braveheart, Amadeus, and Lethal Weapon, and we'll give a d-dimensional location. Here for this simple plot, it's a two-dimensional location in the space, and so all the movies will, in this example, live at a point in this two-dimensional space, And then we're also going to give a location to each of the users in our database in the same exact space. And then, for example, this person is close to Braveheart, and so even though this person is not rated Braveheart, or I have no information about what this person thinks about Braveheart, because I have learned that Braveheart is close to this person, I'm going to assume that this person would like that movie. So these location-based methods that we're going to discuss today make recommendations based on how close things are to each other in a latent embedding space that we have to now learn from the data.